Okay, so now we're dealing with the last 4 questions on the sheet. Let me mute that.
Gene was already out.
And let's see, mute that. Okay. All right, so you've had some experience with this part. So on this part, we're actually solving a radical equation. All right, so number 19 you had on the quadratics test. X equals the square root of 4x plus 21. Okay. All right, so on this one, on these problems, you have to do something to undo the radical because you'll have like a variable that's trapped underneath a radical. So on this one, what I'm going to do, or what we learned to do, is that squaring undoes square rooting. So I'm going to come in and square both sides. All right, now when you do, you must check because this could introduce extraneous solutions. That means solutions that don't work in the original problem. So you have to be careful. Even though you did everything correct, you might get extraneous solutions. And here's the deal. When I square both sides, the squaring undoes the square root, and I get a 4x plus 21. The reason I squared both sides is this right here was a square root. It had an understood index of 2. It was really a square root. They just didn't have to write that. So to undo it, I squared both sides. Okay. If I'm dealing with cube roots, I would cube both sides. Okay. So these 4 problems I don't think you're going to find very difficult. All right. So what we learned is that the resulting equation might be quadratic, like it is here. This is quadratic. So I'm going to use quadratic techniques. I'm going to subtract the 4x and subtract the 21 so that I get things equal to 0. Okay, so I just took away the 4x. I took away the 21 from both sides. Okay. And then at that point, I'm just working with this like it's a quadratic equation. So I'm going to factor 21. I'm going to break down into 7 and 4. And I'm going to make the 7 negative so that I get it to work out the way it needs to with the negative in front of the 4x. I'm going to set each factor equal to 0. And then I'm going to solve those linear equations. So variable on one side, numbers on the other. And I get x could be 7 or x could be -3. Now here's the deal. Those 2 answers are as long as I didn't make an arithmetic mistake, they're going to work here in x squared equals 4x plus 21. So these, at this point, these are the possible solutions here. But you don't want to circle those until you've checked them, okay? So you're going to go back to the original equation. You're going to put a 7 where the x is. And you're going to ask yourself, does that work? Then you're going to put a -3 where the x is. Get that in there. Put a -3 where the x is and see if that works. Let me change that to red. Okay, so you're just checking whether these really work in the original is what you're supposed to be doing. All right, so if you look at this one, this is 28 plus 21. That is square root of 49. Principal square root of 49 is 7. That's what it was supposed to be. So that checks. Over here, this is -12. -12 plus 21, that would be 9. But the principal square root of 9 would be 3, not -3. So this one doesn't check. Now, sometimes these will both check. Sometimes one checks, but the other one doesn't. And it's not always the negative one. So the possible solutions were 7 and -3, but -3 didn't work in the original problem. Okay. So like the original problem we had, before we squared both sides was x equals square root of 4x plus 21. After we squared both sides, we got x squared equals 4x plus 21. So On this one, x equal -3 or 7 are solutions. But on this one, only x equals 7 really works. Okay, so the algebraic process actually, when you square both sides, you actually introduce potentially some extra solutions. They call them extraneous solutions. And so you have to check, that's part of the process on this, to see if they really do work. Okay, and I'm not checking for an arithmetic mistake. I'm assuming my arithmetic is correct. I'm just checking to make sure that it wasn't an extraneous solution. Now later I can explain it better once you've had Math 112, because if I put a negative here, I know that can't be the case because over here I have the principal square root, which would be positive. It has to do with issues like that, okay? So for now, you'll just plug it in and you'll know to rule it out. So that would be your only answer, just 7, okay? So that's number 19. All right, let's check number 20. All right, so on question number 20, what did we have there? We had cube root, and it was cube root of 2x plus 5 equals -5. All right, so it's the same concept. Sorry, it's the same concept. I'm just going to move that out of the way. It's just we had a cube root. So to undo that, we need to cube. And by the way, if you're doing cube roots, you don't have to check your answers. Kind of has to do with how square roots can get things that are imaginary, but cube roots can't. It's sort of because of that. So you don't really need to check. Okay, if you have you're not checking to see whether your possible solution really works. If you didn't make an arithmetic mistake, then you know your answers will work. Okay, so if we cube both sides here, the cube will undo the cube root, and you'll get just 2x plus 5 with no radical. Then over here, think about that as -5 times -5 times -5, or just do it on your calculator. You get a -125. Now this equation, unlike the previous one, this is just a linear equation. So you're just going to take away 5. So 2x would equal -130. Divide by 2. And you get x equals -65. And then I'm assuming my arithmetic is correct. Then that should be my answer. Okay. All right, let's try another one. See, that wasn't too bad, was it? It's just the idea now that it was a cube root, we cube both sides rather than just squaring both sides. It's what I like about math. It's very logical. Look for those patterns, those connections that you can make. So here's another cube root problem. Cube root of 7x equals the cube root of 4x minus 9. Oh, that's weird. The radical's on both sides. So let's see, my x's are trapped under the radical, so I need to get rid of the radical. So I'm going to cube both sides. Okay, so when I do, this cube undoes the cube root, and I get just 7x. On the other side, the cube undoes the cube root, and I get just 4x minus 9. Right, now this has kind of a funny feel to it, but notice how it doesn't have any squares in it. It's just a linear equation. So your plan should be just to subtract the 4x. That'll give you 3x. That's gone, equals -9, then divide by 3. So x equals -3. And then since it was involving cube roots, that should be true, and I don't really need to check it unless I'm worried about my arithmetic being correct. So that will be my answer on that one. All right, and then for our finale, let's look at number 22. Okay, I like this question. This would be a good one question to ask on an exam because it covers a lot of the skills we've had earlier in the course. That was minus x equals 6. Okay, so here we have a radical, but the weird thing here is we got the square root, but it's not isolated yet. So you must isolate the radical. That's one of the big things before you wind up raising it to the appropriate power. Before raising both sides to a power. And you know, if it's cube root, I'm going to raise it to the third power. If it's square root, I'm going to raise it to the second power. But I'm not going to do it right now. I got to get that radical isolated. So let me get the x over to the other side first. Then I would get to here. Okay. And then once the radical's isolated, to get the x from under the radical, I would square that side. But if I square that side, I have to square the other side. This is one where if I'm going too fast, just pause it and think about it as I go through it. Okay, the reason we picked squaring is because it undoes square rooting, and so you should just get the 2x plus 15 on that side. But now, on this other side, you really have x plus 6 times itself. So you want to write it twice so you can FOIL that and not mess it up. Okay, it's not x plus 6 squared is not x squared plus 36. That's the big mistake people make. It's x squared plus 6x plus another 6x plus 36. So the middle terms don't cancel out. You get 12x there. So just do the math. Okay. And so at this point, I'm kind of ready to see, well, how do I need to finish this up? And I'm noticing that squared, which tells me this is quadratic. And that kind of directs what I'm going to do from here. So I like to have my x squared term on the left-hand side. So you can do it without moving the two sides around, but I just noticed that people do better when they get it in order with the ax squared plus bx plus c right there on the left. So I just move the two sides around. I don't think that should bother you too much. Equal sign, so these two can be switched around and it doesn't matter. Then I'm going to subtract the 2x and subtract the 15 from both sides. So see how that's gone and that's gone. So that's equals 0. And then here I have x squared plus 10x plus 21. Okay. And the reason I approached it that way is it was quadratic. So I knew I wanted to get it equal to 0. Then I'm going to try factoring. It does factor into x plus 3 and x plus 7. Then I'm going to set those factors equal to 0. Okay. And I'm going to get two answers, -3 or -7. Okay, subtract 3 here, subtract 7. And those are two answers. Those are my possible. Just for now, all we know is that they're the possible solutions. But remember, you squared both sides, right? Up here at the beginning, we squared both sides. So right there, you need to make a mental note and tell yourself you must check. Squaring and raising things to the fourth power, those are the ones that have to be checked. Okay, so I'm going to take the original equations now, the original equation now, all the way back to the very original before I did anything, which was this. Okay, and it's getting dark out here. Okay, this, and then I'm going to check. So I'm going to plug in the -3 for x, and this is a little weird. So let me make sure that's clear. So that's 2 times the -3 plus 15 and the radical right there. Then you have minus -3, and the question is, would that be 6? Okay. And then I'm going to plug into that equation. Let me just write it again because I have to be so careful. And I'm going to do square root of 2 times, this time a -7, plus the 15, and that radical, minus, and then in place of x, put the -7. And I'm wondering if that will turn out to equal 6. Okay, so let's see. So this would be -6 plus 15. So I get principal square root of 9 minus a negative is plus 3. That would be positive 3 plus 3 would be 6. Does check. Okay. 2 times -7 would be -14. Plus 15 would be 1. Square root of 1 is what I got there. Minus -7 would be plus 7. This would be 1, but when I add 7, I get 8. I don't get 6. All right. So the -3 worked. The -7 did not. Only -3 is the answer. Gotta check. When you square both sides, you could introduce extraneous roots. Okay. All right, so that's the last problem on that page. So